We're looking at derivatives of trig functions, and our book reminds us that a derivative is this limit of the difference quotient there. And they give an interesting example about how that relates to the derivative of the sine, stating it looks like it's cosine. And then a little while later, they actually prove the derivative of the sine using a couple of limits that we derived way back in chapter 2. So since they do a great job of proving the derivative of the sine, I'm going to prove the cosine. Leave it to you guys to read the book. Off we go. So according to the textbook in their proof, the derivative with respect to theta of the sine of theta is the cosine of theta. And what I am going to justify right now is the derivative of the cosine of theta by going back to the definition of the derivative. So that would mean I have to figure out what is the limit as h goes to 0 of my f of x plus h. In this case, that would be theta plus h. So I'm going to have the cosine theta plus h minus the original function, in this case cosine of theta, all over h. And if we try to cheat and just throw it h equals 0, remember this limit is approaching, not equal to 0, but if we cheat and actually plug in 0, what we're going to get is 0 in the numerator and 0 in the denominator, which is indeterminate, which means I got to do some work on this. Now, since I can't really do a direct subtraction between these two here, because they have different arguments inside, theta plus h versus theta, but I do know there is a cosine angle sum formula. So I'm going to apply that. And we're definitely going to need a bunch of trigonometric identities in this section. So carrying on my limits, actually, no, we're just going to do a little algebra and come back to the limit. Let's get rid of that. It's going to be tedious carrying that along. So we'll come back to the limit in a minute. We're going to do a little side work here. So what is the cosine of theta plus h? Well, if you look that identity up, or maybe you remember from your trig course, that is the cosine of theta, cosine of h, minus the sine of theta, sine of h. And so from this, we need to subtract our cosine. Now I'm going to regroup things a little bit. I have to subtract a cosine of theta. There happens to be a cosine of theta right here, so I'm going to put those guys next to each other. So reordering that numerator, I have cosine of theta, cosine of h, this first term here. And then I'm going to bring this minus in there. So minus cosine of theta. And then I have to finish by subtracting that. Sine of theta, sine of h. And the reason I did that was now from these two terms here, I can factor out the common cosine of theta. So now I have, I'm going to pull the cosine of theta just from those first two terms. And that's going to leave behind a cosine of h minus 1. And then we still have that minus sine theta, sine h hanging out. So then, and there's really not much more I can do with this, it doesn't clean up anymore. But what I can do here is I can divide by the h and bring the limit back in. So I'm going to come back up here to my limit, and I'm going to separate it into two limits. So I'm going to have the limit as h goes to 0 of this first part divided by h. So that's the cosine of theta times cosine of h minus 1, all over h, and then minus the limit as h goes to 0 of the sine of theta, sine of h over h. And I can clean this up further. The cosine of theta here, it's got no h in it, so it can pop out of the limit. The sine of theta here has no h in it, so it can pop out of the limit. So as far as the limit is concerned, sine of theta is a constant. As far as this limit is concerned, cosine of theta is a constant, and we know we can put constants out of limits, so I can rewrite this again. So this is going to be the cosine of theta times the limit as h goes to 0 of the cosine of h minus 1 over h minus the sine of theta times the limit as h goes to 0 of the sine of h over h. And these limits here we've dealt with before. So way back in section, what was this, like 2.3, 2.4-ish, somewhere in there, we found out that the limit of this part right here, sine of h over h as h goes to 0, that right there goes to 1. That was a very complicated one to deal with. We had to look at the unit circle, and we had to compare an arc length to the sine and the tangent. It was quite an elaborate proof to get to that, but we did eventually show that that was 1. This one right here is just an algebraic proof, and that one was also done way back in chapter 2. And it turns out this one right here goes to 0. So based on those prior limits, we have cosine of theta times 0. So that whole part right here is gone. That's a big 0 there. And then we have the negative sine of theta times 1. And so we're done. We get negative sine of theta. So 2 big important rules. And based on those, we can do all other trig functions. We now have this derivative of the sine is the cosine. And the derivative of the cosine is the negative sine. And now we have power over derivatives of trig functions. Yeah.